I remember when I was learning synthetic division at GCC, you know, 30 some years ago, that I had a problem distinguishing or knowing the relationship between factors and zeros. So let me try to explain. They're related. These terms are sometimes almost interchangeable. If I give you a polynomial like f of x equals to x minus 5 times x minus 3, I would say the factors of f of x are x minus 5 and x minus 3. The zeros I get by setting the factors equal to 0, just like finding an x-intercept. So these are the factors. The zeros of a polynomial you get by setting the factors equal to 0. It's just like finding the x-coordinate of the x-intercept. Here, if I set this equal to 0, that x minus 5 would give an answer of 5, and this would give an answer of 3. So the factors of my polynomial are x minus 5 and x minus 3. The zeros of my polynomial are x equal to 5 and x equal to 3. The reason we call zeros zeros is because if you plug them in, if I evaluate f at either one of the numbers, if I evaluate the function at 5, I'd get 0 times 2, which is 0. The reason I call 5 a 0 of the polynomial is because if I plug it in for x, I get 0. Similarly, if I plug 3 in for x, I get 0. So zeros and factors are related. In this next group of problems, I'm going to use my calculator to find zeros, and they're going to be x-intercepts, because look, this algebra that I did here is the algebra that I do to find x-intercepts. So I'm going to find zeros, which are kind of the x-coordinates of x-intercepts, and I'm going to turn the zeros into factors. When I do synthetic division, I use the 0 as opposed to the factor. So in the next chunk of problems, I'm going to have to create the synthetic division problem myself. So each of the problems between 11 and 20 give me a polynomial, and they want me to use synthetic division to completely factor, just like I did in the first bit of problems, but it doesn't give me a starting point. How do I get a starting point? That's where part A is. I'm going to, on my graphing calculator, I'm going to graph the polynomial, and I'm going to find a 0, which is the x-coordinate of an x-intercept. There's probably going to be 3 different ones. I just need one of them, and any one of them will be fine. And let's get to this started. Let me clear out anything that I have in my calculator. And so now in my y1, I'm going to put this function in number 12. So x cubed plus 8x squared plus 11x minus 20. And I don't need a particularly accurate graph. I just need to be able to see the x-axis okay. Not dig in the... maybe that's better. I'm going to go zoom standard. I don't care about the maximum or minimum points. I just need to find the x-intercepts. Whoa, that's just not viewable. So there's 3 different x-intercepts. I just need to know the x-coordinate of one of them. If I have my choice, I'd like to work with a positive x-intercept. I'm going to try to find the x-coordinate of that x-intercept. And I can do that pretty quickly by hitting my second in table button. And I look for y's in my zeros in my y column. and find a corresponding x. So for part A, to use my graphing calculator to find an x-intercept, I really just want the x-coordinate of the x-intercept. And I'm going to use x equal to 1. I could have used x equal -5. I could have used x equal to -4 because those are all x-coordinates of x-intercepts. So I say that x equals 1 is a 0. And what does that mean? That means if I went to this problem and plugged 1 in for x and if I did 1 cubed plus 8 times 1 squared plus 11 times 1 minus 20, I'd get 0. That's what it means to be. That's what it means to be a 0. The x-intercepts of functions are zeros. And immediately, if I know that x equals 1 is a 0, I also know that x minus 1 is a factor. Because in order to get a 0, in order to get x equal to 1 for a 0, or the x-coordinate of x in an x-intercept, I'd have to set x minus 1 equal to 0. If I set x minus 1 equal to 0, I'd add 1 to both sides and get x equal to 1. So it's going to be important in this section to know the relationship between zeros and factors. If I have a factor, I could set it equal to 0 and find the x-coordinate of an x-intercept, which is often referred to as a 0. Or I could go backwards. If I have a 0, I can figure out the factor that created it by just changing the sign. So now I'm going to do my synthetic division. Take the coefficients for number 12, which are 1, 8, 11, and minus 20. And I'm going to put the 0 outside my division bar. I've set this up to get a remainder of 0. If I pick points that have y-coordinates of zeros, specifically if I pick x-intercepts, I'm setting this up to get a remainder of 0. In fact, these are the x-intercepts are the only numbers that I can do synthetic division with to get a 0 at the end. So let me do this. Bring down my 1, multiply, add, multiply, add, multiply, add. So this is going to be 1x squared plus 9x plus 20. I lower the exponent by 1. Remainder of 0. So part A was just saying I'm going to use x equal to 1 for my synthetic division. Part B is now completely factor the polynomial. I know the polynomial that I started with, the x cubed plus 8x squared plus 11x minus 20, it's going to have two factors to start. The factor that came from the 0, which is x minus 1, times the result of my synthetic division. Since I got a remainder of 0, I can use it to factor. This is considered partially factored. This bit here is going to factor more. And to get my complete answer to part B, I'm going to take the parentheses x squared plus 9x plus 20 and split it into two parentheses. I'm going to take the x squared and make it firsts in both my parentheses. And the 20, I'm going to turn into the 9. I'm going to end my parentheses with two numbers that multiply to 20 and add to 9. And it's going to be 4 and 5. To finish up my factoring, I need plus 4 and plus 5 because 4 times 5 is 20 and 4 plus 5 is 9. That's it for my answer to part B. I did my synthetic division. I got a remainder of 0. I used the factor that was implied by the part of the x-intercept with my answer to the synthetic division to partially factor, and then I factored my answer to the synthetic division to completely factor. That's the end of part B. Now I'm going to move on to part C. Part C says solve the function equal to 0. And I know that this right here, this is a factored form of the function. So really it's just asking me to solve x minus 1 times x plus 4 times x plus 5 equals to 0. That one would give me x equal to 1. That's going to give me x equal to -4. This is going to give me x equal to -5. I actually knew all those answers from my graph because these are the three x-intercepts. but the answer to 12C in any order are the numbers 1, -4, and -5. This is 100% of everything that's for the rest of the section, other than the factoring gets harder. So for each of the problems, I'm going to sketch a graph, find any one of the x-intercepts. It has to be an x-intercept that's an integer for this to be sane. After I find the x-intercept, I'll create the factor that's implied by the x-intercept to help me with my factoring. I'll do the synthetic division, use the factor created by the x-intercept times the answer to my synthetic division that had a remainder of 0 to partially factor, then factor the work from the synthetic division down to a couple factors. That will end part B. For part C, I'll take this, which is a rewrite of the original problem, set it equal to 0, and get my numerical answers. There should be 3. So, problem 14, I'm going to start and I'm going to graph 2x cubed. I think this calculator is just working better right now. 2x cubed minus 5x squared minus 4x plus 12. I'm going to zoom standard it because I don't know what this window was set for. And if by glancing at the graph I can figure out an x-intercept, I'm good. It looks to me like there's an x-intercept at 2 and it has even multiplicity. Let me see, by going second in table. It is. So the answer that I'm going to write for part A is going to be x equal to 2, which means I'm going to have a factor of x minus 2. I even know better, it's probably x minus 2 squared. But anyways, the answer to part A, I used my graphing calculator to get a x-coordinate of an x-intercept, which we call a 0. And I know that the factor that I'm going to get from that is x minus 2. I'll pretend like I don't know it's x minus 2 squared, but I think it's going to be, specifically because of the way the graph looked. Now I'll start my synthetic division. This 2 I'm going to put outside the bar, and then my coefficients of 2, -5, -4, and 12. If I don't get a remainder of 0, I've messed up. So if that doesn't happen, I did something wrong. Bring down the 2, multiply 2 times 2 is 4, add, the numbers have opposite signs, I subtract and take the sign of the larger and get -1. Then 2 times -1 is -2. Add, because they have the same signs, I add and keep the sign and get a -6. Multiply, add, and get a 0. So I won't worry about my remainder. I'll take this and increment down from an x cubed to an x squared. The synthetic division gives me 2x squared minus 1x minus 6. I'm going to need to factor this. Ultimately, right now, I know that in part B of number 14, that 2x cubed minus 5x squared minus 4x plus 12 is going to factor into x minus 2 times 2x squared minus 1x minus 6, but I need to factor that. That's hard factoring. I usually put one of these on the test because you should, in a college algebra class, be able to factor this. So off to the side here, if I wanted to factor 2x squared minus 1x minus 6, I'd multiply the 2 and the minus 6 and get a minus 12. I'm looking for numbers that multiply to -12 and add to -1. That's going to be -4 and +3. If you multiply those, you get -12. If you add those, you get -1. I teach factoring by grouping, but you don't have to use grouping. If you know how to factor this and you know a different strategy, then don't factor like this. But this is the way I teach factoring when we have a number in front of the squared term. Use those two numbers to break the polynomial up into 4 terms. And then 1 parentheses common factor. First parentheses factor out of 2x. Be left with an x minus 2. Second parentheses factor out of 3. Be left with an x minus 2. This is really fast because I'm not teaching factoring. I'm just trying to get something on paper so that maybe you can follow it. If you knew how to factor at one point, but you forgot just a little bit, those would be the steps. Again, my intermediate algebra section 1.4, I explained this much slower and much clearer. So I can finish up part B by taking this and writing it as x minus 2 times 2x plus 3. And for an answer to part B, I might write it with that exponent of 2 that I knew the x minus 2 had to have by the way the graph looked. That's done with part B. I've completely factored my polynomial. Part C just wants me to solve the polynomial equal to 0. So I'm just going to set the factored form of this equal to 0. That guy gives me an answer of 2, would give me an x-intercept of 2, 0, multiplicity 2, which is even. This guy is going to give me the fraction answer that I probably couldn't have got that easily on my calculator. I'm going to subtract 3 and divide by 2 and get x equal to negative 3 halves. So my answer to part B, solving f of x equal to 0, I get x equal to 2, which is the answer that I had in step 1, and then the additional answer of negative 3 halves. When I graph this, the graph touches the x-axis at 2. That's the x minus 2 squared. And this right here, that's at negative 3 halves. And that, I couldn't really get so nicely other than with algebra and factoring. Oh, let's do 15 together. I don't know that it's any different than 16, but let's do 15. For part A, I'm going to graph this. Y equals clear 6x cubed minus 29x squared minus 62x plus 120. And quite honestly, I don't care what the graph looks like. I can go directly to the table, so second in table, and try to find a 0. And I'm not seeing a 0. I'm glad we're doing this one. Maybe I entered this wrong. 6x cubed minus 29x squared minus 62x plus 120. Doesn't seem to be working right now. I wrote a key for this, so 6x cubed minus 29x squared minus 62x plus 120 equals second table. Something's wrong. Oh, there it is. Something's not wrong. I just didn't go far enough. So finally, I usually don't make my numbers that big, so I didn't even think to search that far. Nothing's wrong. I just was impatient. So my answer to part A is going to be x equal to 6, and that's going to help me when I go to factor. X minus 6 is going to be one of the factors. When I go to do part B, which is the synthetic division part of this to help me completely factor it, which is kind of the bulk of what I do, the 6 is going to go outside the upside down division bar, then 6 minus 29 minus 62 and positive 120. Bring down my 6, multiply 6 times 6 and get 36. And then just to be safe, second and quit to get to the main screen, minus 29 plus 36 is 7. Then 6 times 7 is 42. Minus 62 plus 42 is minus 20. 6 times minus 120 is minus 20. I get a remainder of 0. The synthetic division gives me 6x squared plus 7x minus 20, remainder of 0, which means now I know how to factor 6x cubed minus 29x squared minus 62x plus 120. I'm going to factor it into x minus 6 times 6x squared plus 7x minus 20. I wish this was an in-person class because I wrote a quadratic formula program that gives answers that are fractions, and I could turn the answers into factors. But assuming we're living in the world of COVID, let me factor this by hand. So off to the side, I need to factor. However I factor, you could use bottoms up if you were taught that and remember how to do it. I'm going to start and multiply the 6 and minus 20 and get minus 20. I'm going to look for plus minus numbers that multiply to minus 120 and add to 7. And 120 is not such a good number for me. Let me do 120 divided by, oh gosh, 15, does it work? Yeah, it's 15 and 8. So the numbers I'm going to need are negative 8 and positive 15. Because if you multiply those, you get negative 120. And if you add those, you get positive 7. That's a big lift. I wouldn't put numbers that big on a test. So that means I can take the problem that had 3 terms, rewrite it with 4 terms, introduce parentheses. In the first 2 terms, I'd factor out a 2x and be left with a 3x minus 4. The second 2 terms, I can factor out a 5 and be left with a 3x minus 4. So this whole thing's going to factor into the common factor of 3x minus 4, followed by what's in front of the common factors, 2x plus 5. So for my answer to part B of number 15, this whole guy factors into x minus 6 times 3x minus 4 times 2x plus 5. It'd be nice if I named this. This is the f of x function. Part B wants me to just take f of x and set it equal to 0, because this is f of x in part C. I'm just going to take this and set it equal to 0. That guy's going to give me an answer of 6. I don't need to do that by hand. The 3x minus 4 factor is going to give me an answer of 4/3, because I would add 4 and divide by 3. And the 2x plus 5 factor, I'd minus 5 and divide by 2 and get minus 5/2. The answer to part C are just those 3 numbers, x equal to 6, positive 4/3, and negative 5/2. And you can write those in any order. There isn't a right nor a wrong order. 2 more problems to do, and they're going to have i's in their solutions. They're going to have the second piece not factor, which is actually nice. So I'll do 18. To start on 18, I'm going to graph the function that's given. So x cubed minus 4x squared plus 9x minus 36. Second in table, I don't really care what the graph looks like. I just need a number in the x column that has a 0 next to it in the y column. That's going to be x equal to 4. So x equal to 4 is my answer to part A. When I go in my factoring, the factoring that comes from the x equal to 4 is going to be x minus 4. So synthetic division, 4 out front, then 1, negative 4, 9, and negative 36 above that upside down division bar. Bring down the 1, multiply, add, multiply, add, multiply, add. The result of my synthetic division is x squared plus 0x plus 9, remainder of 0. If in this second group of problems, the 11 through 20, you don't get a remainder of 0, you've made a mistake. So my answer to part B, at least the partial factoring, is going to be x cubed minus 4x squared plus 9x minus 36 is going to equal to x minus 4 times x squared plus 9. This, section 1.5 in intermediate algebra, is prime. It doesn't factor. This is considered completely factored. That can't be made into two parentheses unless you factored with i's, which we don't generally do. So that's a sum of squares. That's prime. 18c, and again, this is called f of x for what it's worth, supposed to set the function equal to 0, and this is just a factored form of the function. So the best thing to do is set x minus 4 times x squared plus 9 equal to 0. The x minus 4 gives an answer of 4. The x squared plus 9 doesn't factor. And to solve it, I'm going to minus 9 from both sides and get math that's not hard, but I don't remember doing recently. We do it in intermediate algebra, and we do it in Math 114. To solve this, I would isolate I'd move the 9 over by subtracting it, and then square root plus or minus square root, and I get plus or minus 3i. Anytime when you solve a polynomial and you get an I, it's prime. It would never factor. So my answer to part C is x equal to 4, positive 3i, and negative 3i. That's not the nicest way to write it. It would be better to say the answer is x equal to 4 and plus or minus 3i. One more to do, I think, is a twin of this problem. In fact, let's do 19 together just to knock out one of your homework problems. So I'm going to graph 19 for part A. Y equals x cubed plus 4x squared plus 25x plus 100. Nice having all those pluses. Peek at a table. There it is. Negative 4 is where I'm shooting for. So the answer for this is x equal to negative 4. When I get down to part B to do my factoring, the factoring that's going to come from it is x plus 4. So we're doing 19. For my synthetic division, negative 4 up front, 1, 4, 25, and 100 under. Bring down the 1, multiply negative 4 times 1 and get negative 4. Add and get 0. Multiply negative 4 times 0 and get 0. Add and get 25. Multiply negative 4 times positive 25, get negative 100. Get a remainder of 0. The synthetic division gives me 1x squared plus 0x plus 25, remainder of 0. So that tells me in 19b how to factor my function. I don't even need to write the function down. I could just say this is called f of x. It factors into x plus 4 times x squared plus 25. I don't need the 0 pieces. That x squared plus 25 is also prime. You can move on to part C. Set the function equal to 0. You set the factored form of the function equal to 0. The x plus 4 gives an answer of negative 4. And the x squared plus 25 is going to give me plus or minus 5i. And to get that, I'll minus 25 from both sides. That will give me x squared equals negative 25. And then square root plus or minus square root. The square root of a negative gives me an I. The square root of 25 gives me a 5. So that's plus or minus 5i. And my answer to 19c is going to be x equal to negative 4 and plus or minus 5i. Right at 30 minutes, that's a good enough stopping point. I think the next section's a short one. 5.3 and 5.5 are short. 5.4 is going to be monsterly long. Not particularly hard, just long.